Hello to myself and everyone watching this video. This is the fourth video I've recorded, and the third one I've uploaded to this YouTube channel. I didn't upload the third recording because I feel my reading wasn't very good, and yeah, I try to stay consistent with this series. And so just promise. And today's topic is about science. It's called brain development and function. So let's go. Brain development and function. The brain is our most amazing organ. It allows us to think, dream, speak, and make decisions. It is one of the things that makes us humans. It controls everything we do, such as breathing, enjoying a bowl of ice cream, or deciding which cell phone to buy. Scientists have been studying the brain for thousands of years. They are only now beginning to understand its structure, function, and development. The brain is part of the nervous system, which consists of billions of special cells called neurons. These neurons consistently send information back and forth at very high speeds from different parts of the body to different parts of the brain. The scientists now understand that these different parts of the brain have separate functions. The brain stems. This part of the brain resembles the brains of many animals. It controls functions like respiration and heart rate. In other words, it controls the essential functions automatically. The cerebellum. This part of the brain controls muscle and movement. New research suggests it is also involved in thinking. The thalamus. This part of the brain helps the brain stem, but it also plays an important role in memory and emotional responses. The cerebral cortex. This is what we usually think of as the human brain. This is the center of cognition, that is, where thinking and decision making takes place. It is divided into 4 parts, or lobes. Each lobe is responsible for different functions, including vision, hearing, speech, movement, and memory. Together, they allow humans to process information and to respond to it. New technologies have allowed us to learn a great deal about the structure of the brain. Technologies such as CT scans and MRIs provide images or pictures of areas deep within the brain. For example, in the 1980s, scientists were able to use MRIs to study amygdala, the brain center of emotion. This important but tiny structure had been invisible on images prior to MRIs. This technology plays a very important role in helping doctors understand the brain and diagnose serious diseases such as brain cancer. Technology can also show how the brain processes information. It shows the area where activity is occurring. It works like this. A doctor places a patient in an MRI machine. The doctor then asks the patient to solve a math problem. For example, as the patient thinks about this task, blood flows to the part of the brain responsible for solving mathematical problems. This area then lights up on the MRI image and indicates activity. The MRI machine makes image of the blood flow so the doctor can assess if the brain is working normally. The development of this technology has allowed scientists to understand more about which parts of the brain are responsible for different functions. Scientists are also interested in cognitive development, or how the brain grows and ages. They have found that the brain does not develop at a consistent rate before a child is 2 years old. There is a surge in brain growth and development. During these early years, billions of new neurons are added to the brain. Each one is connected to thousands of other neurons, making trillions of connections. These connections are very important because all information to and from the brain must pass through these connections. Scientists have found that babies start out with more neural connections than others. These extra connections allow a baby to learn new skills such as language. However, after the age of 3, a new process begins. At this age, the brain begins to keep track of the connection that is used the most. Neural connections that are used a lot remain strong and survive. Connections that are not used a lot become weak and are lost. For example, a child who has books to read at an early age may learn to read more easily than a child who has no access to books. Understanding more about neural connection has also changed belief about old age. People used to think that the brain reached its peak at about 40 and after that began to decline. Now, scientists believe that older people who stay physically and mentally active continue to make and keep neural connection. This means that even at an older age, adults can still learn new skills. However, it often takes older adults longer to learn a new skill because the rate at which the brain processes new information slows down as an older age. At the same time, however, the different parts of the brain begin to work together more efficiently as it ages. This helps to compensate for or make up for the loss of processing speed. As life expectancy continues to lengthen, doctors are becoming more interested in understanding how the brain ages. There is still a great deal that we do not know about the brain, but 21st century technology is allowing scientists to research the brain in new and exciting ways. This technology will help us understand more about how the brain works and help doctors better diagnose and treat brain disease and injuries. So that's all for the topic of today within brain development and function. Thank you for listening and see y'all. Hopefully, see y'all every day. Consistent posting, recording and posting video. Promise. See ya. Thank you.